Let's take a look at graphing these quadratic functions. We'll start out graphing a quadratic function in the form ax squared plus bx plus c. Here's the graph we're going to try to create, x squared plus 2x minus 2. The first question, determine whether the parabola opens upward or downward. The a value actually tells us that. If a is positive, the parabola opens up. If a is negative, the parabola opens down. So here in this problem, a is 1, 1 is positive, and so since a is positive, we've got a parabola that opens up. Determine the vertex of the parabola. So we'll be looking at first a formula and then using something called completing the square to get the vertex form of the quadratic function. So we'll first use the formula to find the vertex, and then we'll use that to actually create the vertex form, but then we'll also use completing the square to find the vertex form of the parabola, of the quadratic function. And we'll do that in a later problem. So starting out, the x-coordinate for our vertex is given by this formula here, negative b over 2a. Looking at our problem given, a is 1, b is 2, c is negative 2. When we're talking about a, b, and c, we don't include the x's in there. Notice their x's are not included in our original general form of a quadratic function, ax squared plus bx plus c. So when we talk about a, b, and c, we're only talking about numbers, not the x's. Using a equals 1, b equals 2, c equals negative 2, I can plug these values into this equation for x, and I can find my vertex of the parabola. Negative b over 2a, but b is 2, and a is 1, so I have negative 2 over 2, and negative 2 divided by 2 is negative 1. To find the y-coordinate, I take that negative 1 and I plug it into the function. So x squared plus 2x minus 2. I'm going to plug in negative 1 where x was. And then we simplify. Negative 1 squared is 1. 2 times negative 1 is negative 2. Minus 2. 1 minus 2 minus 2 is negative 3. So we end up with a vertex of negative 1, negative 3. Once we have the vertex using this formula, then we can write the vertex form of the function. F of x, a stays the same as 1, x minus something squared plus something. So I need to find the two somethings. Well, I already found the two somethings. The reason that this is called vertex form, the way this is written, is because h and k are the values of my vertex. So here, this is h, negative 1 is h, and negative 3 is k. So I can drop those in, negative 1 and negative 3, but I don't like having signs next to each other like that. That's awkward, so we're going to clean it up. X minus negative 1, that's x plus 1 squared, plus a negative 3 is really a minus 3. With the vertex form, we can see the translations that are happening as well. Remember, our original function is just x squared. So by having the plus 1 inside with the x, that gives us a left shift, and the minus 3 outside is a translation down. And I just answered problem number 4. If we compare this function to y equals x squared, how has the graph been shifted? I know it says graph, but we're going to look at the vertex form of the equation. F of x, x plus 1 squared minus 3, x squared, the original, is shifted down 3 and left 1. You can also see this down 3 and left 1 in the values of our vertex. The shifted vertex indicates how it was shifted. Number 5, determine the axis of symmetry. Axis of symmetry is x equals the x coordinate there, negative 1. Find the y-intercept by evaluating the function at x equals 0. For this, I'm going to go back to the original function, f of 0, x squared plus 2x minus 2. I plug in zeros, 0 plus 0 minus 2. Negative 2 is my y-intercept. These points are going to become very important because we're going to put them in our table. When we create a table for graphing a parabola, we're going to start out with the vertex in the middle. So our vertex was negative 1, and we already plugged it in. F of negative 1 is negative 3, so I won't repeat that part. We've done it before, above. So our vertex is negative 1, negative 3, vertex. We also found the y-intercept, x equals 0, and we got negative 2. There's another ordered pair. So for the other values for x, and you do want to pick 5 numbers, 5 inputs to find ordered pairs for your graphing your parabola. Since a is 1, I'm just going to go numerically around the vertex by 1. So negative 1 and 0 are already there, so I'll go up to 1, and then I'll go down to negative 2 and negative 3. Plugging these values in, 1 squared plus 2 minus 2. This will give me 1, so 1 comma 1. If I plug in negative 2 and simplify, I get negative 2, negative 2, negative 2. And then to plug in negative 3, 9 minus 6 is 3 minus 2 is 1, negative 3, 1. I have 5 ordered pairs that I can then plot on my plane. So that's what we're going to do. First up, let's draw our axes. You can make your axes wherever you want to on this kind of graph. Just try to make it so that you can input all 5 of those points on your graph. There's my x and my y. When you are creating a graph from scratch like this, you do need to make sure that whoever's looking at your graph understands what the boxes represent, that they represent one whole unit. So you do need at least 2 values, if you don't want to fill them all out, 2 values on the x-axis and 2 values on the y. I do have 5 on both of mine. Just know that you need, at a minimum for my class, 2 values on each axis, okay? Once you have that, then we can start graphing our quadratic function. I'm going to start at the vertex. This is always where I start. Negative 1, negative 3. There's my vertex. And then 0, negative 2, and 1, 1. What's really cool about our parabolas, and the reason that we also have this thing called an axis of symmetry that goes through the vertex, is that our parabola is perfectly symmetric. And you don't have to go all the way up to the top. But our parabola is symmetric. What do I mean by that? Pop back up here on the table and check out the values around the vertex. The values around the vertex, the y values, are the same. If you put your vertex in the middle and you choose x values around it in a uniform manner, this will happen. This is the beauty and the pattern of mathematics that occurs. But you do have to be intentional with the values that you pick for x. You cannot be random. You have to be intentional. Use the information that we just had, all the information we did before, to answer the following questions. Does the quadratic function have a maximum or a minimum at the vertex? Well, the vertex here is at the bottom of the graph, so we definitely have a minimum. All of the other values of the graph are above that vertex. Identify the maximum or minimum value of the function. The value of the function is the y value of the vertex. The maximum or minimum value, this is going to be a minimum value. We've already determined that. Y coordinate of the vertex is negative 3. The interval where the function is increasing. So understanding that we haven't really talked about this, the idea we're increasing and decreasing is you are a person and you are standing on the graph. You are walking from left to right on the graph. Lowest x values to highest x values, right? So small x to large x. If we're on this side of our parabola that's graphed, we're walking downhill. Downhill is decreasing. If we're on the other side of the parabola, and we're walking left to right. We're going uphill and we're increasing. This idea of decreasing and increasing becomes important, particularly in later classes, but it is good to identify them now and make sure that we can understand where that break point is. So where does it change from decreasing to increasing? The vertex. The vertex makes the change. So the interval where the function is increasing, for this graph, we are increasing to the right of the vertex. So we have the vertex x value. Oh, I should point this out too. This notion of where corresponds to x's when we're talking about functions. So the interval where the function is increasing, we would say from -1 to infinity. And for this particular situation, it does not matter whether you use a square bracket or a parentheses. There's a lot of debate whether you include the value or not. I'm not going to make a big deal about it. So if you use a parentheses or a square bracket, no big deal for me. I'll take both. Your college algebra or calculus teacher may think otherwise, but I'll leave that for them to argue. The interval where the function is decreasing, we would do the opposite side of the vertex, so the -infinity to -1, or using the parentheses for that one. I've seen texts go both ways. I've seen texts where they say include the turning point. I've seen texts where they say don't include the turning point. I don't think there's a standard rule for it. Identify the domain of the function. We already have. It's a parabola. The domain is all real numbers. The range of the function, well, the range of the function starts at our minimum value, that y-coordinate of the vertex, -3, and goes up to infinity. So it starts at -3 and goes up to infinity. Good job on graphing your parabola. Try on your own the guided example 2, graphing -x² plus 4x plus 5. You're going to go through the exact same steps that we did before. The biggest difference in this graph, other than the 4 and the 5 instead of the 2 and the -2, is we have a negative sign in front of x². That's going to change some things with our graph, but I'm going to let you try to discover that one on your own and come back and check on the OneNote when you get it done.